Okay, so now I come to 10.4 operation on radical expression. In this session, we have some things that need to know, such as like radical. Um, so like radical have the same index and the same radical. Okay, so such as um, 7 square root 5 and 3 square root 5, they are like radical with the square root number 5. And next one, I have 5 cube root of AB and 1 cube root AB is also like radicals. Also, I have cube root of 5 and cube root of 4. In this one, unlike radical, because they have different radical, even though they have the same index, right? It's 3, but they have different. We have cube root 7 and square root 7. They are unlike radical because even though they have the same radical as 7, but they have different index as 3 and 2. You see that? So remember that. Um, Only these two cases are like radical, okay? Um, for the adding and subtracting radical expression, um, in order to adding and subtracting radical, you cannot combine unlike radical, such as square root 2 and square root 5. Okay, but sometimes you can rewrite radicals and then combine them. Okay, so let's take a look at the first example over here. I have a 6 square root of 13 and add with 13. So you can right away you can add them because they are like radical, right? Because they have square root 30, right? To this term they have square root 13. So you can combine to this because the first term have 6 and the second one can be write as 1 square root of 13. So it's like you adding 6 square root 13 plus 1 square root 13, which is 7 square root 13, right? Okay, so the second one, you have same index, okay, but different radical. In this case, um, you may have tried to figure out if you can rewrite a radical and make it be like radicals, and then you can combine them. So in this problem, I believe that square root of 40 can derive as square root 4 times square root of 10. And in this case, you can have two terms that have the square root 10, and that make you have like radical, right? And then you can combine these two by simplify the square root 4 become 2, right? And then 2 minus 2 square root 10 minus 1 square root 10 gonna be just square root 10. Okay, so that is a way to adding and subtracting radical. Remember that for adding and subtracting radical, you need to have like radical, like radicals. Okay, so if you don't have you have unlike radical, you must try to rewrite it to become like radical. Another thing is cannot combine if we have different index. You cannot adding or subtracting. We have different index. Okay, so if you have something such as square root of 4 and then square root 2 and then plus with cube root of 3, you cannot combine it unless you can simplify something that make it be like radical. Okay, so let me move to the next one. Okay, so the next one say multiplying radical expression. For multiplying radical expression, it actually can sometimes be multiplied like binomials. So you can see over here, we have like square root of a minus 5 multiplied by square root of a plus 5. So the distribution you can have such as like square root of a multiplied by square root of a, and then plus with 5 square root of a, and then next one give you minus 5 square root of a, and plus with minus with 5 times 5. So that's give you square root of a square minus 5 square, because these two cancel, and that's give you only a minus 25, right? So that's the reason why you have 25 over here. So okay, and the second one have let me delete this. The second one have x square root of x minus 3 multiplied by square root of x plus 1. So you can also do as square root of x times square root of x. We're gonna give you x, and then square root of x times 1 becomes square root of x, and negative 3 times square root of x can be negative 3 times square root of x, and then negative 3 times 1 become negative 3. So combined like term, you have x x minus 2 square root x, right? This is square root x minus 3 square root x, gonna be negative 2 square root x and minus 3. Okay. Okay. And now we're gonna move to the conjugate. So what is conjugate? Most people are gonna learn about conjugate before moving to the next level of the mathematics. So the conjugate is found by changing a plus sign to a minus sign, or vice versa. So let's have an example. It's kind of easy. So for example, I have square root of x plus 7. What is the conjugate of that? It is square root of x minus 7. And what about square root of a minus 2 square root b? What is conjugate of this? You're going to have square root of a plus 2 square root of b. So what is the difference between two this? Just plus and minus, just plus and minus. You see that? So or you can have like a minus b. What is conjugate of this? It is a plus b. Just that, easily. Okay. This is conjugate. conjugate. What about if I say, hey, what is the conjugate of a plus b? You can go back of this. It's going to be a minus b. Okay. So similarly, what is conjugate of a square root of a plus 2 square root of b? It is square root of a minus 2 square root of b. Okay. Just to keep in mind that. Now, let's clear this. And now I'm going to talk about rationalizing a denominator that has one term. We're going to write the quotient without a radical expression in the denominator. Okay, so this is in order to have the simplified form. You don't want to have a square root or any radical expression at the bottom. So you see something like that, 5 square root, 5 divided square root of 7. You don't wanna say, oh, this is simplified form. No, it's not. Okay, even though it's look nicer than 5 times square root of 7 divided by 7, but this actually is simplest form. Okay, and I mean, honestly, I don't really I don't really worry about this because I mean, to me, I accept even this, but you know, this mathematics, and we must follow some rule that they define. So they say we don't want to have radical at the bottom, and so in order to do that, it must multiply by some by itself or some way that make the radical gone. So in here we have square root of 7 at the bottom. You must multiply by square root of 7, so you can have square root of 49. We're gonna give you 7 at the bottom, but the top has to multiply by square root of 7 also. So top now become 5 times square root of 7. Okay, so that's the reason why we talk about rationalizing a dot denominator that has one term. Okay, so what about two term? If we have such a like 1 divided by 2 minus square root 3, something like that, you cannot easily multiply by itself, right? Because it will not make a square easily. So in this case, you always think about the conjugate. You multiply with conjugate at the bottom, right? So it's gonna help you to square the square root 3, and that make become 3. And the top just multiply by this, but it doesn't matter with a radical on the top. So now you have the answer at 2 square root of 3. Okay, so this is some important thing from section 10.4, but let's we go ahead and have some example for to go on it. Okay. Now let's start with example 1. I have adding radical. So I have I have square root of 12 plus 7 square root of 3. Okay, so you see that this is not like it's not like radical yet. You need to rewrite something. You need to rewrite or need to change radical to one radical to become having like radical. So usually you're gonna take a look at the big radical. So what's a big radical right now? Let me use other color over here. So the big radical was square root 12. So you need to rewrite this one. I know that 12 can be rewrite as 4 times 3, right? So I'm gonna rewrite as it as square root of 4 times 3 plus 7 square root of 3, and I can rewrite as square root of 4 times square root of 3 plus 7 square root of 3. And now I can have 2 square root of 3 plus 7 square root of 3. Okay, let me rewrite this. Okay, now combine like term you can have as 2 plus 7 square root of 3. So 2 plus 7 square root of 3, which equal to 9 square root of 3 as the answer. Okay. So now let's move to B. If I have, say, 3 square root 2 plus square root 8 plus square root 18. Okay, so we can see that in here I have the smallest radical is smallest radical is square root of 2. So what I need to do is I need to convert all the bigger one to become like radical square root 2. So that's my strategies, and let's start with square root 8 become square root of 4 times 2. Okay, and the second one going to be 9 times 2, right? And I can rewrite as 3 square root 2 plus square root 4 times square root 2 plus square root 9 times square root 2. And I can rewrite it again as 3 square root 2 plus 2 square root 2 plus 3 square root 2. And combine like term, you will have 3 plus 2 plus 3 square root 2. And that will give you 3 plus 3 plus 2 equal to 8 square root 2. That's going to be the answer. Okay, let's say C. Okay. Yeah. 1 second. Oh, man. You can see I have for root of 32 plus 3 for root of 2. Okay. So now, what do I need to do? In here, what is smallest radical do I have right now? I have 2. So I need to convert the 32 to have the like term radical, which radical is 2. So I have the first one I can rewrite as 4 root 16 times 2, right? And then plus 3 4 root of 2. And now I have, you know that I can, let me rewrite it down here. I have 4 root of 16 times with 4 root of 2, and a plus with 3 times 4 root of 2. Now I have 4 root of 16 equal to, you know that it's going to be equal to 2. Because, you know what, I'm just going to rewrite as 4 root of 2 to power 4 here, so people can know. Multiply 4 root of 2 plus 3 square 4 root of 2 again. And now I have 2 4 root of 2 plus 3 4 root of 2. And that's given you 2 plus 3 parentheses 4 root of 2, right? And that's answer gonna be 5 4 root of 2. That should be the answer. Okay. Let's have maybe the next one. What is that? C already, right? Now I move to D. Let's do 8 minus, oh no, 8 cube root of 5 minus 3 cube root of 5 plus cube root of 11 . All right. So I have now I can I have in here, I have a subtraction, right? You see that? And how can I do this one? I know that the smallest radical in here is number 5. Okay, 5. And can I convert radical 11 to 5? I don't think so. So what I do is I just gonna combine these two only, because you can't not do anything with 11, right? You cannot factor 11, so there's no way for you to combine this cube root of 11. So I gotta stay cube root of 11, and one with cube root of 5 over here. I gonna combine it as 8 minus 3 times with the cube root of 5. And that giving you 8 minus 5 is 8 minus 3 is 5 cube root of 5 plus with a cube root of 11. Okay. All right. So what else? Maybe have last one. D and E, right? So I have 5 square root of Z plus cube root of Z minus 2 square root of Z. Okay, now I think it's special case. You know that's right where you can combine these two, right? But the middle, can you do anything? Try to simplify first. Okay, you need to simplify this cube root of Z, but you cannot, right? And also it have different index, so you cannot do anything for that. So cube root of Z gonna be stay. Okay, and you have 5 square root of Z minus 2 square root of Z gonna be 5 minus 2, because it is like radical, so you can combine that square root of Z and you plus with this. So that gives you 3 square root of Z plus cube root Z. The answer should be it. Okay. All right. Okay, you know what? We have in here an example with quotient, right? So let's have f cube root of 5x divided by 27 and then minus with a cube root of 5x divided by 6 over here. So you see that there's no like radical right now, but if you take a look at the first and second one, there is 5x right with a cube root, but you must rewrite the first term, right? You must rewrite the first term over here to become like cube root of 5x over here. So how can you write it? You need to apply the quotient rule, so such as split the top and bottom. So cube root of 5x divided by cube root of 27, and then minus for the cube root of 5x divided by 6. Cube root of 27, you know that it's going to be equal to 3. So I rewrite this as cube root 5x divided by 3 minus 4 cube root 5x over 6. Okay, so in order to subtract fraction, you must have the same denominator. So I'm gonna multiply by 2 for top and 2 for bottom to get 2 cube root of 5x divided by 6 and minus cube root of 5x divided by 6. So now you're gonna have what? 2 cube root of 5x minus cube root of 5x divided by 6. And finally, you will have 2 cube root of 5x minus 1. So 2 minus 1 cube root of 5x divided by 6. And that's giving you 1 only, which is 3 cube root of 5x divided by 6. Okay, so that should be the answer. Okay. Okay, so let's have example 2. Example 2. So what did I do in example? Oh, adding, subtracting, right? Okay. Example 2, I would like to have, let's say, subtracting. Radical. Okay, so hey, I have 4 root of 81, 8 over 3, b over 6 minus the 4 root of 16 a and b squared. That will give you so in order to do this too, in order to do this subtracting radical, I would love to say simplify it first, right? So in order to simplify for each term in here, you need to factor out the perfect power for each term. For the first term, the perfect power 4 gonna be 81, 8 to the power 4, and b to the power 4. That's gonna be power 4 perfect power. Okay, 4 perfect power. And then remember that we still need to multiply by the 4 root of a times b to power 2 in order to make it from here to here. Right, we see that one term now split to become 2 terms, and you minus with 16 times 4 root of a times b squared. Right. Okay, so now you have the first term become 3. Remember, 4 root of 81 is 3 times a times b. Multiply by 4 root of a times b squared, and then minus with 4 root of 16 become 2 times 4 root of a times b squared. You can also notice that usually if you start with something like that, you can try to think about if you can have like a like radical with a times b squared over here. Okay, so that's why I split out the a and b squared from the first term. Okay, so let's move to the next problem. So b, I have 3 times with a square root, no, cube root of n to the power 5, cube root of n to the power 5, divided by 27, and a minus 2 times with the cube root of n to the power 2. So you know that which one in here is which one is lowest power. I know that is n square over here, radical. So you may have to think about the way to convert this to write like radical as n square with the root 3. So you have 3 study, right? Apply the quotient rule. You have cube root of n to power 5 divided by cube root of 27, and a minus 2 cube root of n squared. So this guy, the cube root 27, can be rewrite as 3. Let me put 3 on top here. 3 times with the cube root of n to the power 5 become n to the power 2 times n to the power 3. You know what? Let me rewrite it to the next row. 3 times cube root of n to the power 2 times n to the power 3, because n to the power 2 times n to the power 3 equal to n to the power 5, right? And divided by cube root of 27, which is 3. Okay, so I'm gonna minus for 2 cube root of n to the power 2. And now I can have I can cancel top bottom 3 and 3 here, and I can I can rewrite as cube root of n to power 3 multiplied by cube root of n to power 2 minus 2 times cube root of n to power 2. So now I actually have like radical already, and I also can simplify the cube root n3 become n only, multiplied by cube root n square minus 2 cube root of n square, and simplify. You're gonna just factor n minus 2 and cube root n square over here. Gonna be the answer. This is the answer. Okay. So let's move to the next page. Okay. Next we move to the multiplication. So example 3. Multiplication. So we have a square root b minus 4 times with square root of b plus 5. So you can have what? B times square root of b gonna be b with square root of b squared. Okay, let me just write this better. And then b times 5 gonna be plus 5 square root b, right? And then minus 4 times square root b gonna be minus 4 square root b. Minus 4 times 5 will be minus 20. And then you can have combined like term in the middle, and the first term become only b plus with square root b only and minus 20 as the answer. So there is the answer. Okay. Let's move to the problem B. Let's say 4 plus square root of 3 times 4 minus square root of 3, right? These conjugate each other, okay? And you have, since it's conjugate, you can just know that it's right where going to be the formula. 4 square minus square root 3 square. And that's giving you 16 minus 3. And that gives you 13 as the answer. Okay. Okay, let me talk about rational example 4. Rationalizing the denominator. So let's say I have 1 over square root 2. How can I rationalizing this guy? I'm gonna just multiply by square root 2 for both top and bottom. I should use the other color. So I multiply by 2 square 2 for top and square 2 for the bottom. And now I'm gonna have square root 2 for top. Bottom will be square root 2 times square root 2 equal to square root 2 square. And that's giving you square root 2 divided by 2. That's the answer. Okay. And then let's move to the B. So I have, let's say, square root of x over 24. Okay, so for this one, what you're gonna do, you can apply the quotient rule and split it to become square root x divided by square root of 24, right? But remember that at the bottom right now, you still have square root 24. At the bottom here, you can also factor. Try to simplify first. Let's see what you're gonna do. You have square root of x divided by. Can you factor a perfect square from 24? You know that it could be 4. Let me see. 4 times 6, right? So that can be rewritten as square root of x and square root 4 times square root of 6. That's giving you square root of x times 2 times square root of 6 divided by 2 square root of 6. Okay, but now you need to make sure there is no square root at the bottom. In this one, you have square root of 6 at the bottom. So you need to multiply by the square root of 6 for the top and square root of 6 at the bottom. And since you have square root of 6, you're going to have square root of 6x using Poisson rule on the top. And the bottom going to be become 2 square root 6 square, and that's right. Let me rewrite this. Square root 6 square. Okay, so and then in this case you can have answer as square root of 6x divided by 2 times 6, and then it can be rewritten as square root of 6x divided by 12 as the answer. So this is the answer. Okay. Now let's have C with some conjugate stuff. I have 3 plus square root of 5 divided by 2 minus square root of 5. So how can you take away the square root at the bottom? You need to multiply it by conjugate of it, right? Remember that's okay that you have like 2 term addition and subtraction over here at the bottom. The only way is multiply with the conjugate of it. So firstly, try to have the parenthesis first. And you're going to multiply by the conjugate at the bottom, not conjugate at the top, because you consider to make the conjugate, make the bottom become no radical. So 2 plus square root 5, and then top also have to multiply by 2 square root 5. Okay. So for this one, now you can have equal to top become 3 okay, so 3 plus square root 5 times 2 plus square root 5. Bottom gonna be 2 square minus square root 5 square. And now you can multiply the top and have 3 times 2 equal to 6. 3 times square root 5 gonna be plus square root 3 square root 5, and then square root 5 times 2 going to be plus 2 square root 5. And square root 5 plus square root 5 times square root 5 going to be 5. Divided by 2 square going to be 4 minus 5. And now, come by like term, you have 6 with 5 become 11. Okay, 11. 3 square root 5 plus 2 square root 5 gonna be 5 square root 5. Okay, like 3 apple plus 2 apple, 5 apple. 4 minus 5, -1. And and if you want to simplify one more time, you're gonna have -11 minus 5 square root 5. Okay, so that should be the answer for this problem. Okay. I have D. I have square root x over square root of x minus 2. Right. Now let's see what happened. What you want to do in order to get rid of the square root at the bottom over here? Again, you still have to multiply to the conjugate of this guy. So that's, what is the conjugate of this one? Square root of x plus 2. Square root of x plus 2 for top and bottom. And now you're going to have multiply the top. You have square root of x times square root of x going to be x. Square root of x times 2 going to be 2 square root of x. And then divide by the conjugate multiply going to be the form as square root of x square minus 2 square. And now you're going to have what? X plus 2 square root of x divided by x minus 4. And that should be the answer. Okay. So, anything else? I think maybe have a last one. E. Special one. And it make it become red. Have find cube root of x. Okay. So how can you get rid of this cube root at the bottom? You have to remember that in order to have, in order to get rid of the cube root, you should know that you should have the perfect perfect of 3, the power 3. So I would like to change this cube root become x to the power 1/3. Okay. So in order to get like x, instead of to get the power 1/3, I'm gonna have x equal to x to the power 1/3 multiplied by x to the power 2/3. So then when it multiply each other, the power adding is gonna be x to the power 1, and that's make you have no more root 3 at the bottom. So what I do is I have to multiply by or I should convert this become 5 to the power x to the power 1/3. Okay. And then I'm gonna multiply both top and bottom with x to the power 2/3. x power 2/3. And now I'm gonna have 5 times x power 2/3 divided by x at the bottom. Or x power 1/3 plus 2/3. And then you have 5 x power 2/3 at the top. Bottom going to be x power 1, which is x. And if you stop here, that's okay for me. If you want to rewrite it in the form as radical, you can have 5 times cube root of x power 2 divided by x. And that should be okay too. So I have finished section 10.4. And I hope that you have understand this session. And let me know if you have any question, and see you in the next session. Okay.